For this video, I will discuss the problem number 2 in the problem set 3.1, which is all about equilibrium of rigid bodies. So let's proceed. A T-shaped bracket supports the four loads shown. Determine the reactions at A and B if alpha is equals to 100 millimeters. So in this problem, we will determine the reactions at A and B using the concept of equilibrium of rigid bodies. So the first step in the static equilibrium analysis of a rigid body is the identification of all forces acting on the body with the free body diagram. So we will draw the free body diagram of the problem and try to analyze it. So this is now our free body diagram. So here in point B, we put two forces acting on it. The forces along y direction and the forces along x direction. Here in point A, the direction of force here is in downward direction. The same with these four forces acting on x-axis. And these are the specific distances in each forces. So in order to determine the force here in point A and in point B, let's proceed to the solution. So, solution. The summation of all forces in x is equals to 0. So with that, you can conclude that force of B in x direction is equal to 0. It is because all forces here in the free body diagram are only in upward and in downward direction. That's why the force here in B in x direction is equals to 0. So in order to determine the force here in point A, summation of all moments in point B is equals to 0. So we have negative force of A times its distance from point B. This 60 plus 60 is equals to 120 millimeters. Minus 40 Newton times 60 millimeters. These two moments is in negative signs because they are in the left side of the Cartesian plane, which is in the negative x-axis. So that's why they have these negative signs. Plus 30 Newton times 100 millimeters. Since alpha is equals to 100 millimeters, plus 10 Newton times 100 plus 80 is equals to 180 millimeters, all equal to 0. So by simplifying, you can obtain the value of F, the force in A, sorry for the negative sign. The force of A is equals to 2,400 Newton times millimeters divided by 120 millimeters. So by simplifying, let's cancel millimeters. We have force in A is equals to 20 Newton in downward direction, because it is given here in the free body diagram. So this is the value of the force in point A. So in order to determine the force here in point B, the summation of all moments in point A is equals to 0. So we have force in point B along y direction times 120 millimeters. Since 60 plus 60 is 120, minus 40 Newton times 60 millimeters. Since 40 Newton is 60 millimeters from point A, minus 50 Newton times 120, it is given here in the free body diagram, minus 30 Newton times its distance from point A, that is 100, oh sorry, that is 220 millimeters, minus 10 Newton times its distance from point A, it is 300 millimeters, all equal to 0. So by simplifying, we can obtain the value of force in point B along y direction is equals to 18,000 Newton times millimeters divided by 120 millimeters. So by division, cancel millimeters, we have the value of 150 Newton. Since the value here in the force of B in x direction is 0, we can conclude that force of point B is equals to 150 Newton in upward direction, since it is given here in the free body diagram. So this is the value of the force in point B, 150 Newton upward direction. So that's it. Thank you.